You've been told the story of stars since you were young. They are born in clouds of gas and dust. They shine for millions or billions of years and then they die. Some end quietly, shrinking into white dwarfs. Others go out with a bang, collapsing in a supernova and leaving behind a neutron star or, if massive enough, a black hole. That's the tale we thought we understood. Clean, simple, final. But what if that story was incomplete? What if there was something in between, something stranger, more haunting, and far more beautiful than we ever imagined? Right now, the James Webb Space Telescope, humanity's most advanced eye on the universe, may have caught a glimpse of such a thing. Not just another star, not just another black hole, but perhaps the first evidence of a black hole star, a star so massive that at its heart rests not fusion, but a dark singularity devouring matter while the star around it still shines. Think about that for a moment. A star powered not by light, but by darkness. A star that should not exist yet might have lit up the early universe. This isn't science fiction. It isn't a scene from a Marvel film or a line from a comic book. This is real science, cutting edge, unfolding now, and it challenges the very way you think about creation itself. For decades, scientists believed black holes were cosmic destroyers, the end of the road, the villains of the sky. But what if, in the very beginning, they were the creators? What if black holes helped shape the universe, not by tearing stars apart, but by powering them into existence? That is the myth-busting twist you're about to explore. Because this isn't just about one strange observation, this is about the entire story of how the universe became what it is. You take a breath and imagine the night sky the way ancient humans once did. Before telescopes, before science, before names like James Webb or NASA ever existed. Back then, stars were seen as gods, spirits, ancestors. They were eternal fires marking the heavens. The idea that a star could die, let alone collapse into a black hole, would have seemed absurd, even blasphemous. And yet, here you are, living in an age where science tells you stars are not eternal. They are fragile, finite, governed by physics, doomed to burn out. That realization has always carried a kind of melancholy. Every twinkle you see at night is a reminder of something temporary. But now, Webb's discovery whispers something different. That maybe in the beginning, there were stars unlike any we've seen since. Giants so vast, so strange that they rewrote the rules. And at their core was something that feels impossible to imagine, a black hole wrapped in light. To really understand how shocking this is, you have to pause and look at the machine that made it possible. The James Webb Space Telescope is not just another gadget. It is humanity's most ambitious mirror, polished to perfection, floating 1,000,000 miles from Earth. It was built to peer back in time, to catch the faintest glimmers of the first galaxies, the first stars, the first structures of creation. And in that silence of deep space, Webb may have spotted something that doesn't fit the script, a light too bright, a star too strange, a signal that doesn't match the models. The idea that it could be a black hole star has sent shockwaves through the scientific community, because if true, it solves a riddle that has haunted astronomy for decades. How did the earliest black holes get so big, so fast? You see, the universe is only 13.8 billion years old. Yet, by the time it was barely 500 million years old, there were already supermassive black holes, millions, even billions of times the mass of the sun, sitting at the centers of newborn galaxies. That shouldn't have been possible. Black holes shouldn't grow that fast. And yet, there they were. Scientists scratched their heads, argued, built theories, tore them down. Maybe the black holes were born large. Maybe they gobbled matter faster than we thought possible. Or maybe, just maybe, they grew inside the bellies of stars. That's where this story bends toward the incredible, because a black hole star, if it existed, would be exactly the kind of nursery needed to grow those giants. So here you stand at the edge of a discovery that is both myth-busting and awe-inspiring. The villain of the cosmos, the black hole, may have once been a hero. The thing we fear, the devourer, the abyss, may have been the lightbringer, the creator, the seed from which galaxies bloomed. It's an emotional twist that forces you to rethink your place in the cosmos. Because if stars themselves can be born with black holes inside, what else might we be missing? What else has the universe hidden in plain sight, waiting for us to build the right telescope, ask the right question, look the right way? Now picture this. Billions of years ago, when the universe was still a baby, the first black hole stars glowed. They weren't small, they weren't delicate, they were titans, thousands of times more massive than our sun, their light blazing across the newborn cosmos. And deep inside each one, a dark heart pulsed, feeding, growing, shaping the future. When you look up tonight, you won't see them. They lived and died long ago. But the light they left behind, the faint whispers Webb is catching, still travels through space, still reaches us now, like a ghost story written in starlight, crossing billions of years to find your eyes. That's what this documentary is about. Not just science, not just data, but a journey, a cosmic detective story, and you're invited to walk through it. Because at the end of this path lies a truth bigger than any one discovery, that the universe is stranger, more alive, and more mysterious than we've ever dared to dream. So lean back, let your imagination stretch, and prepare to see the night sky the way James Webb sees it, through the eyes of a machine built to look into the past and maybe, just maybe, to show us the beginning of everything. To understand the discovery, you first have to understand the machine that made it possible. Because the James Webb Space Telescope isn't just a piece of technology, it's the closest thing humanity has built to a time machine. Think about it this way. When you look at the moon, you see it as it was just over a second ago. When you look at the sun, you see it as it was 8 minutes ago. And when Webb peers into the cosmos, it sees galaxies not as they are now, but as they were billions of years ago when the first stars flickered to life. That's what Webb was built for, to chase the echoes of creation itself. The story of Webb begins long before it ever reached space. In the 1990s, after the Hubble Space Telescope had shown humanity breathtaking views of galaxies and nebulae, scientists began dreaming bigger. Hubble was extraordinary, but it had limits. It could see deep, but not deep enough. It could measure light, but not the faint whispers stretched by cosmic expansion into the infrared spectrum. If you wanted to see the first galaxies, the first stars, the very dawn of the cosmos, you'd need a new kind of telescope. Something bigger, something colder, something beyond Earth's reach. The idea was ambitious, maybe too ambitious. A telescope with a gold-plated mirror as wide as a tennis court. A telescope that would have to be folded up like origami to even fit inside a rocket. A telescope that had to unfold itself in the vacuum of space, a million miles from Earth, with no possibility of repair. If it failed, it would fail forever. For years, Webb was ridiculed as the telescope that ate astronomy. The budget ballooned. Deadlines slipped. Engineers worked sleepless nights to fix problem after problem. At one point, critics suggested canceling it altogether. Billions of dollars had been spent, and all anyone had to show for it was a dream. And yet, the dream refused to die. When the Ariane 5 rocket finally roared to life on Christmas Day 2021, carrying Webb on its back, it wasn't just a launch, it was a leap of faith. Scientists, engineers, and dreamers held their breath as the telescope began the most complex self-deployment in the history of space exploration. Over the course of a month, 344 single points of failure had to work perfectly. If even one failed, the telescope would be useless. But it worked. Every latch, every fold, every movement, flawless. Slowly, the golden mirror unfurled. The sun shield stretched. The instruments cooled to cryogenic temperatures. And the telescope, perched far beyond Earth's orbit at the L2 point, opened its eyes, and what it saw changed everything. The first images stunned the world. Galaxies crowded into view where Hubble had shown only emptiness. Webb revealed thousands of stars hiding in dusty nebulae. It captured light from galaxies so old, so faint, that they had been invisible until then. But beyond the beauty was the purpose. Webb was designed to answer one of the most profound questions of all. How did the universe begin to take shape? To do that, it had to look for the earliest stars. Not the ones in our galaxy, not even the ones in nearby galaxies, but the first stars to ever ignite in the aftermath of the Big Bang. These were stars unlike anything we see today. Enormous, short-lived, blazing with intensity. Some were so massive they burned out in just a few million years. And some, perhaps, were stranger still, black hole stars. Uh, Now imagine being one of the scientists behind Webb, sitting at your desk, staring at the first data streams trickling in. You've spent decades working toward this moment, and suddenly you're looking at light that's traveled for 13 billion years. You're literally seeing the past. And then tucked inside that data, something catches your eye. A signal that doesn't match. Too bright, too strange, too powerful for a normal star. The first thought isn't triumph, it's doubt. Maybe it's an error, maybe it's a glitch, maybe the models are wrong, but as the data is checked and rechecked, the realization sinks in. This might be something new, something never seen before. That's how discoveries happen. Not with a thunderclap, but with a whisper. With a scientist squinting at a graph and thinking, doesn't look right. And from there, the whispers spread. Meetings are called, papers are drafted, words like candidate and possible are used with care. Because science doesn't leap, it crawls, it questions, it resists. But behind those careful words, there is awe. Because Webb may have done what no other telescope has ever managed. It may have glimpsed the first evidence of a black hole star. To you sitting here, that might sound abstract, just another headline in a world of headlines. But take a moment to let it sink in. The machine that made this possible wasn't inevitable. It wasn't easy. It wasn't cheap. It was a gamble of billions of dollars, decades of work, and thousands of people who believed that the pursuit of knowledge was worth it. And in that gamble, we may have won something extraordinary. Proof that the universe is far stranger and far richer than we dared to hope. Because if Webb really has found a black hole star, it means the universe has secrets left to tell. It means that creation itself is more mysterious than we thought. And it means that for all our science, all our progress, we are still just children staring up at the stars, asking questions. Webb is not just a telescope. It's a reminder of what humans can do when we refuse to give up, when we refuse to stop asking, when we decide that even the faintest starlight, stretched across billions of years, is worth chasing. That's why this story matters, because it's not only about what Webb found, it's about what it means for you, for all of us, to live in a universe where the impossible can still be real. And as we move deeper into this documentary, you'll see how that one discovery, a light too bright, a star too strange, connects to the very foundation of cosmic history. For all the years of theory, debate, and speculation, science always comes back to the same thing: evidence, numbers, data, light itself traveling across unimaginable distances to land in our detectors. And in 2023, the James Webb Space Telescope delivered a set of observations that left astronomers blinking at their screens. It began as part of a survey designed to peer into the cosmic dawn, the first few 100 million years after the Big Bang. Webb's infrared instruments were tuned to catch the faintest galaxies forming in that ancient time. And in one corner of the data, buried among the patterns of redshift and light curves, something stood out, a signal too strong. A brightness that didn't match any known model of a newborn galaxy. Imagine it. You're part of the research team, running through calibration checks, ruling out instrument errors. At first glance, you expect to find a mundane explanation, maybe a glitch in the detector, maybe contamination from a nearer object. But the more you test, the stranger it becomes. The object is real, it's distant, and it's shining far more intensely than any ordinary star cluster should. For weeks, the discussions spiral. Could it be an unusually large star, a cluster of many stars overlapping, or perhaps more exotic, something never directly observed before? Slowly, a possibility surfaces. This might be the signature of a black hole star. The very phrase feels like science fiction, a star with a black hole inside, a cosmic paradox. But the numbers are persuasive. The luminosity is higher than expected for its apparent size. The energy output doesn't match ordinary stellar processes. There's a hint of something extraordinary happening within the object, something feeding it from the inside out. Here's where it gets even more intriguing. Normal stars shine because fusion in their cores produces outward pressure, balancing gravity. But in a black hole star, the black hole at the core swallows matter and releases energy as it does so. That energy can blow outward, heating the surrounding star and making it shine brighter than it has any right to. It's like watching a bonfire fueled not by logs, but by a furnace hidden inside, roaring unseen. And Webb's instruments may have caught the glow of such a furnace. This is where the story pivots from theory to shock, because until now, black hole stars were mathematical curiosities, hypothetical, a what if whispered in the back pages of astrophysics journals. But suddenly, staring back at you from the depths of cosmic time, is an object that behaves exactly the way one of those long-forgotten theories predicted. The emotional impact is hard to describe. For scientists, it's exhilarating, terrifying, and humbling all at once. Exhilarating because you might be watching history unfold. Terrifying because what you're seeing challenges decades of established thought. Humbling because you realize the universe is always a step ahead, always stranger than your models allow. Think about what this means for you. Sitting under the night sky. That point of light above your head isn't just a star. It might represent a kind of object that changed everything in the early universe. For the first time, you can imagine a star that isn't powered by the usual rules. A star that glows not because of fusion, but because a black hole inside it feeds on its own matter. A star that paradoxically lives because something inside it is devouring it. It's the ultimate cosmic irony. Life through destruction. Creation through collapse. A star with a dark heart. The implications ripple outward. If Webb has indeed spotted a black hole star, it helps solve the riddle of supermassive black holes. Instead of waiting billions of years to grow, these seeds could have formed rapidly, nestled inside these monstrous stars, ballooning into giants before galaxies had fully taken shape. It also means that the early universe may have looked dramatically different from what we've pictured. The first light wasn't just ordinary starlight. It may have been this eerie glow, fueled by black holes hidden inside titanic suns. And here's the most astonishing part. You're not just hearing this as a dry scientific fact. You're alive at the very moment when humanity might be seeing these things for the first time. For thousands of years, people looked at the stars and imagined gods, spirits, or eternal fires. Now, with Webb's golden mirror, you're glimpsing something those ancient stargazers couldn't have dreamed of. But science is cautious. The researchers don't declare victory. They don't rush to headlines. Instead, they publish carefully worded papers filled with caveats and questions. Could the brightness come from another process? Could it be a quasar, a galaxy with a feeding black hole at its center? Could it be something else entirely, something we haven't yet imagined? Still, the whisper remains. The data fits. The glow looks right. The theory holds. It's as if the universe itself is teasing us, offering just enough evidence to light the imagination, but not enough to close the case. For you, the listener, this is the engagement trigger. Because you're now part of the mystery. You're sitting at the edge of human knowledge, where every new observation could rewrite the story. Do you believe it's a black hole star? Do you lean toward caution or toward wonder? Would you bet that this is the missing link, The answer to how the earliest black holes formed, that's the tension pulling at science right now. A, a moment of possibility, a discovery balanced on the knife edge between theory and fact. The mystery star Webb may have seen is more than just a bright spot in the data. It's a symbol of how the universe refuses to be tamed. Just when you think you know its rules, it reveals something stranger. Just when you grow comfortable with its patterns, it breaks them. And that's the essence of this journey. Not comfort, but surprise. Not final answers, but deeper questions. Because if black hole stars are real, then the cosmos is darker, brighter, and more paradoxical than we ever imagined. To understand why Webb's possible black hole star is such a revelation, you have to travel back, not just billions of years into the cosmos, but a few decades into human history. Back to a time when the very idea of a black hole was still young. Back to the 1960s. It was an era of enormous change. Humanity had only just begun to launch satellites into orbit. Astronauts were still preparing for the moon landings. The concept of quasars, mysteriously bright radio sources at the edges of the universe, had just been discovered, and the word black hole itself had only recently been coined. For scientists, it was a golden age of wild ideas. In that decade, a small group of astrophysicists started to wonder about something strange. What if, in the earliest days of the universe, stars could form under conditions unlike anything we see today? The young cosmos was denser, hotter, filled with pristine hydrogen and helium. Could it be that such an environment allowed for stars beyond imagination? They began sketching out the math, running crude calculations. What they envisioned didn't look like the stars we know. These weren't suns gently burning hydrogen for billions of years. These were titans, so massive, so unstable, that ordinary physics might not contain them. And within some of those giants, they theorized a black hole might form almost immediately. The name they gave these hypothetical objects was quasi-stars. The idea was radical. A star that wasn't powered by nuclear fusion alone, but by a black hole at its core. Matter would fall inward, feeding the black hole, which in turn would release enormous amounts of energy. That energy, instead of destroying the star, could inflate its outer layers, creating a bloated, shining monster, bright enough to outshine entire galaxies, yet temporary, living for only a short cosmic moment. Quasi-stars would be strange hybrids, part star, part black hole, existing only in the extreme conditions of the early universe. At the time, the theory was more curiosity than conviction. There was no evidence, no telescope could see far enough, no instrument was sensitive enough to detect such ancient objects. It was, at best, an intellectual exercise, a thought experiment scribbled in chalk on blackboards. Most scientists nodded politely and moved on. Quasi-stars faded into obscurity, tucked away in obscure papers, overshadowed by the more pressing discoveries of the day. Pulsars, quasars, cosmic microwave background radiation. But a few kept the idea alive. Over the years, papers reappeared, modeling the physics more carefully. They suggested quasi-stars might solve the puzzle of supermassive black holes. If such stars existed, they could grow black holes inside them much faster than ordinary processes would allow. Still, without data, the idea remained on the margins, an elegant speculation, waiting for proof that seemed out of reach. Fast forward half a century. Humanity now has the James Webb Space Telescope, capable of peering back to those very first billion years, capable of seeing the kind of light no other telescope could. Suddenly, the impossible becomes possible. We can look for quasi-stars, and then in the Webb data, scientists see it. A light too bright, a star too strange, a signal that whispers of a black hole at its heart. It's as if the universe is saying, they were right all along. The emotional power of this moment is hard to overstate. Imagine being a young researcher in the 1960s, mocked for suggesting such exotic objects could exist. Imagine publishing papers no one really believed in. And then imagine, decades later, humanity's most advanced telescope catching the first hints of exactly what you proposed. It's a reminder that science is not just about facts, it's about persistence, about imagination, about daring to ask questions that seem absurd. Every great discovery starts that way, as an idea too wild to fit the current models. The Earth orbits the Sun, continents drift, time bends near gravity, quasi-stars could exist. At first, the world laughs, and then sometimes the universe smiles back and proves you right. For you listening to this, there's something deeply human in that story. You don't have to understand all the physics to feel the weight of it. Because at its core, this isn't just about stars. It's about dreams deferred, rediscovered, and fulfilled. Theories from the past ignored for decades suddenly spring to life when the technology finally catches up. Ideas waiting like seeds in the dark, blooming only when the light of new evidence shines on them. That's the beauty of science. It's not just about answers, it's about patience. It's about holding on to a question long enough for the universe to reveal its truth. Think of it this way. When Webb spotted that strange object, it wasn't just seeing across space, it was seeing across time, both cosmic time and human time, across 13 billion years of cosmic history and across 60 years of scientific history, connecting the imaginations of theorists long gone to the instruments of today. That connection is what makes this discovery more than just data points on a graph. It's a bridge between generations, a story that begins with chalkboards in the 1960s and stretches into the present day. And if quasi-stars, black hole stars, are real, it means those early dreamers weren't just speculating. They were peering into the truth of the cosmos long before we had the eyes to see it. Now ask yourself, how many other theories dismissed today as too strange, too far-fetched might one day be proven? How many other forgotten ideas are waiting in the dark like seeds until we build the right telescope, the right detector, the right question? The story of the black hole star reminds you that the line between imagination and reality is thin. Today's wild idea could be tomorrow's headline, and that's what makes the cosmos so thrilling. It isn't just that we're finding answers, it's that we're learning to ask better questions. So, here you are, standing at the edge of a rediscovery. A theory born in the 1960s, nearly forgotten, now reawakened by the golden eye of James Webb. A reminder that the universe doesn't just confirm our expectations, it often vindicates our boldest dreams. And as you move forward in this story, you'll see what those theorists glimpsed only faintly: the image of a star unlike any other. A star whose light may have shaped the first galaxies and whose memory lingers in the glow Webb has captured. This is no longer just theory. This may be evidence, and evidence changes everything. Close your eyes for a moment and try to imagine a star. Not our sun, not the gentle pinpricks you see at night, but something so massive it defies your sense of scale. A star hundreds of thousands of times the mass of the sun, a sphere of burning gas so wide it could swallow our entire solar system whole. Now, imagine that inside this colossal star, hidden at its very core, is not the usual furnace of fusion, but a black hole. This is the paradox of the black hole star, a star with a heart of darkness. On the outside, it might look deceptively normal, an enormous glowing sphere pouring light into the cosmos. If you could somehow drift near it, the radiation would sear you long before you even saw the star itself. Its light would be blinding, its heat unimaginable. From a safe distance, it would appear like a beacon in the void, brighter than any galaxy you've ever seen. But inside, at its center, something unthinkable is happening. A black hole is feeding. Normally, when a black hole forms inside a star, the story is over. Gravity collapses everything inward, the star dies. But in a black hole star, the opposite happens. The energy released by the black hole's feeding actually props the star up, keeping it inflated, stopping it from collapsing. The physics is mind-bending. As matter spirals into the black hole, it releases radiation, immense amounts of energy that rush outward. Instead of tearing the star apart, that energy sustains it, heating its outer layers, keeping it swollen like a cosmic balloon. The result is a bizarre balance: destruction at the core, fueling creation at the surface. It's like watching a candle that burns because it's being consumed from the inside. Or like standing before a volcano that doesn't erupt but glows endlessly because the magma inside keeps churning. Except this isn't fire or magma, it's pure gravity at work. The black hole star shines not because it's alive in the way we know stars to be, but because it's dying constantly and feeding on itself. That's the eerie beauty of it. The brighter the star, the faster the darkness its heart grows. Now imagine you could stand on some nearby world, if such a world could exist, and watch this thing in the sky. You'd see a star unlike any other. Vast, overwhelming. Its glow would be steady but strange, tinted by the processes happening within. It wouldn't flicker like a campfire or twinkle like stars do from Earth. It would loom constant, like a cosmic sun that never sets. And if you could somehow peer past its blazing outer layers into its soul, you'd see the singularity feeding, a region of space where light itself cannot escape, hidden beneath the furnace of the star's envelope, a void wrapped in radiance. This isn't just a thought experiment. The numbers back it up. Models suggest that black hole stars could reach sizes 100,000 times more massive than the sun. They would be short-lived, lasting perhaps only a few million years, a blink in cosmic time. But during their brief existence, they would shine with such intensity that they could reshape their surroundings. They could carve bubbles into the cosmic gas around them, altering the way galaxies formed. They could pump energy into the early universe, igniting processes that cascaded into the structures we see today. And most importantly, they could grow the seeds of supermassive black holes faster than anything else we know. Think of it this way. If black hole stars really existed, then every massive black hole at the heart of a galaxy might trace its ancestry back to one. The monster at the center of the Milky Way, Sagittarius A Psi, could be the descendant of one of these strange titans. Every galaxy you see in the night sky might have been sculpted, in part, by stars with hearts of darkness. It turns the universe into a kind of family tree, with black hole stars as the forgotten ancestors. But let's pull back from the numbers and think about the emotional weight of this. For centuries, stars have been our symbols of light, guidance, hope. Poets call them eternal. Philosophers call them perfect. We look to them for direction, for inspiration, for permanence. Now imagine telling those same poets and philosophers that some stars were never truly stars at all, that they were monsters hiding in disguise, that their glow came not from purity, but from the slow, relentless hunger of a black hole at their core. It challenges not just science, but imagination. Stars as symbols of light, corrupted by darkness within. The universe revealing a truth that is both awe-inspiring and unsettling. Sometimes even the brightest things are powered by shadows. And yet, here's the twist. Without those stars, without that darkness, we might not be here. Black hole stars may have been the engines that allowed galaxies to form so quickly. They may have created the conditions for stars like our sun, for planets like Earth, for life like ours. Without their paradoxical existence, the universe might have been a dimmer, emptier place. So, you're left with an astonishing irony. The monsters of the early cosmos, these strange hybrids of light and darkness, may have been the very reason you exist at all. Pause on that thought. The next time you look at the stars, remember that behind their beauty lies complexity, that creation and destruction are not opposites, but partners, that the universe itself thrives on paradoxes, black holes giving birth to light, darkness fueling brightness, death creating the conditions for life. A black hole star is not just a curiosity, it's a symbol of the cosmos itself, a place where opposites coexist, where contradictions create beauty, where the impossible becomes real. So when Webb peers into the deep past and hints at the glow of one of these stars, it isn't just an astronomical discovery, it's a philosophical one. It tells you that the universe is stranger than you thought, that the neat categories of science are only stepping stones, that behind the order you cling to, there is always a deeper mystery. And in that mystery, you find something profoundly human, a reminder that just like those early stars, you too are made of contradictions. Light and shadow, creation and destruction, bound together in fragile balance. Perhaps that's why the idea of a black hole star feels so haunting, because in some small way, it reflects us. You've seen the outline of what a black hole star might be, an impossible giant with a heart of darkness. But the bigger question is this: why does it matter? Why are scientists so excited at the possibility that Webb has glimpsed one of these strange objects? The answer lies in one of the deepest puzzles of modern cosmology: how the early universe grew up so fast. Take yourself back to the first billion years after the Big Bang, a universe still in its infancy. Space is filled mostly with hydrogen gas. The first galaxies are flickering into existence. Stars are just beginning to shine, and yet, hidden among these newborn galaxies, astronomers find something that doesn't make sense. Supermassive black holes, not just small ones. Not the kind you get when a single star dies, but monsters millions, even billions of times the mass of our sun, already in place just a few 100 million years after the Big Bang. According to standard physics, that shouldn't be possible. Here's why. If you start with an ordinary black hole, say the corpse of a massive star, it grows by feeding on gas and merging with other black holes. But that's a slow process. Even if you give it a steady diet, it takes billions of years to reach the size of the black holes we see at the hearts of galaxies today. So how did the early universe manage to produce giants so quickly? This is where black hole stars enter the story. Think of them as cosmic shortcuts. Instead of waiting for small black holes to grow over eons, a black hole star could jumpstart the process. Inside its bloated body, the black hole would gorge itself, growing rapidly while hidden inside the star's layers. When the star finally collapsed, it would leave behind not a tiny black hole, but a huge one, tens of thousands of times the sun's mass. That's not just a head start. That's like skipping the first half of the race. With these oversized seeds, the universe could grow supermassive black holes in record time. The mystery of how ancient galaxies hosted billion solar mass black holes suddenly begins to make sense. But the story doesn't stop there. Black hole stars wouldn't just explain the black holes themselves. They might also explain the structure of the universe around them. Picture the first galaxies forming out of clouds of gas. Left to themselves, those clouds collapse slowly, forming clusters of small stars. But if a black hole star was burning nearby, it would flood the region with radiation. That radiation could ionize the gas, heating it, changing its chemistry, shaping the way galaxies assembled. In other words, black hole stars could have been architects of the cosmos, not just strange anomalies. This is where Webb's discovery becomes more than just a curiosity. If Webb has really seen evidence of a black hole star, it's not just spotting a rare phenomenon. It's uncovering a key piece of the puzzle of why the universe looks the way it does. Without these stars, the timeline of cosmic history doesn't add up. With them, it starts to fall into place. Think of it like archaeology. Imagine you're digging through the ruins of an ancient city, trying to understand how it grew so quickly. You find massive stone walls that must have taken generations to build. But then, buried beneath the rubble, you find evidence of an ancient tool, a machine that allowed the builders to move stone blocks faster than anyone thought possible. Suddenly, the speed of the city's rise makes sense. Black hole stars are that hidden tool. They're the secret mechanism the universe used to accelerate its own growth. But let's step back from the science for a moment And think about what this means emotionally. For centuries, humans looked up at the night sky and assumed it was eternal, unchanging. Then, we learned it had a history, a beginning, a story. And like all stories, it has chapters of tension, of rapid change, of drama. The early universe wasn't calm and orderly. It was chaotic, experimental, filled with strange forms of matter and energy that don't exist today. Black hole stars are a reminder of that chaos. They tell us that the cosmos was once a wild place, where laws of physics played out in ways we can scarcely imagine. And that wildness wasn't random, it was necessary. Out of it came the galaxies, the stars, the planets, the conditions for life. Out of chaos came us. So when Webb shows you a faint glimmer of light from billions of years ago, you're not just seeing a star, you're seeing the moment the universe learned to grow faster. You're seeing the engines that shaped everything we know. Uh, you might ask, could the universe have gotten by without black hole stars? Could it have taken a slower path? Perhaps, but then it wouldn't look the same. The galaxies might not have formed as quickly. The stars we see might not have clustered the way they did. Maybe Earth itself wouldn't exist. That's the scale of what's at stake in this discovery. It's not about one star, it's about everything. And here's where the twist comes in. For all our technology, for all our telescopes and supercomputers, we still don't know for certain if black hole stars existed. Webb has given us hints, objects that look too bright, too strange, too early to fit ordinary categories. But confirmation is still ahead. That uncertainty is part of the story. Because science is never about absolute answers handed down like stone tablets. It's about possibilities. It's about building models, testing them, refining them, and daring to imagine what the evidence might mean. So when scientists look at Webb's data and whisper, this could be a black hole star, they're not just making a claim, they're opening a door. And beyond that door lies the chance to rewrite the history of the universe. Pause and let that sink in. The James Webb Telescope, orbiting 1 million miles from Earth, may have spotted the key to one of the universe's oldest mysteries. The reason galaxies grew so fast, the reason black holes became so massive so quickly, the reason you look up at night and see a sky full of stars instead of a void. Black hole stars aren't just strange relics, they're cornerstones of cosmic history. And the more we learn about them, the more we learn about ourselves, because we are the end product of that history. The light from those impossible stars may be gone, but its influence lingers in the galaxies overhead, in the atoms in your body, in the very fabric of the universe you inhabit. That's why it matters. So far, you've heard the theory. You've imagined the scale. You've felt the weight of what a black hole star could mean for the history of the cosmos. But here's the question that really matters. How do we know? How can astronomers sitting here on a tiny planet billions of years later possibly claim that a faint smudge of light on a detector is a black hole star? The answer is detective work, and James Webb is the perfect detective. Think of Webb as less of a telescope and more of a time machine with forensic tools. Unlike Hubble, which sees mostly invisible light, Webb looks in infrared. That's crucial because the universe is expanding. Light from the earliest galaxies has been stretched, its wavelengths elongated by billions of years of cosmic growth. What was once visible in ultraviolet light has been redshifted into the infrared. In other words, the earliest stars don't show up as blue sparks, they show up as faint red glows. Only Webb, with its golden mirrors and ultra-sensitive instruments, can detect them. But seeing the glow isn't enough. Webb has to analyze it. That's where spectroscopy comes in. Spectroscopy is the science of splitting light into its colors, its spectrum. Think of it like listening not just to the melody of a song, but to every instrument individually. When astronomers look at the spectrum of a star, they can tell what elements it contains, how hot it is, how fast it's moving, and even how old it might be. For black hole stars, the spectrum holds telltale signs. A normal star of that brightness would have certain chemical fingerprints, patterns of hydrogen, helium, maybe traces of heavier elements if it's a later generation star. But the object Webb found doesn't fit neatly. Its light is too luminous, too broad, too energetic for its size. It doesn't match what we'd expect from a cluster of ordinary stars either. Instead, the data hints at something more exotic, a single object, impossibly bright, sitting too far back in time to make sense under standard rules. And that's where the whisper starts. Could this be a black hole star? But good detectives don't jump to conclusions. So scientists rule out other suspects. Could it be a quasar? Those are powered by black holes too, and they're very bright. But quasars usually have signatures of surrounding material, disks, jets, radio emissions that don't match what Webb saw. Could it be a compact galaxy? A collection of small stars bunched together? Possibly, but the glow doesn't look granular. It looks smooth, unified, as though it's coming from a single massive source. Could it be an ordinary star that just happens to be unusually massive? In theory, maybe. But no ordinary star should survive with that brightness at that early point in time. Piece by piece, the suspects fall away, and what's left is the strangest possibility of all, the quasi-star, the black hole star. Imagine the scene as a crime drama. The universe is the crime scene. The light is the clue. Theorists from the 1960s left us a case file long ago. Look for a giant star, too bright, too strange, with signs of a black hole inside. And now Webb, like a patient detective, has dusted off that old folder and compared the fingerprints. It's not a perfect match, but it's close enough to send a thrill through the scientific community. Of course, in science, you don't solve a case with one clue. You need corroboration. That's why Webb will keep observing. Astronomers will look for more candidates, more strange glows that don't fit the mold. They'll run simulations, compare the data to models, test every alternative explanation. This isn't about rushing to declare victory. It's about building a chain of evidence so strong that doubt collapses. And that chain takes time. Years, maybe decades. For you, sitting in the present, that might sound frustrating. Why can't we just say it's a black hole star and be done? But that patience is what makes the discovery trustworthy. Science isn't about headlines. It's about rigor. Every bold claim has to survive the fire of skepticism. And here's the human truth behind that. The scientists studying Webb's data know what's at stake. If they call it too soon, they risk being wrong. If they wait and the evidence holds, they get to make history. That's the tension. Living with the possibility of a discovery so extraordinary it could reshape our understanding of cosmic history, but also with the burden of proving it beyond doubt. So as you listen to this story, realize that you're standing in the middle of an unfolding investigation. Webb has opened the first box of evidence. The clues point toward a suspect thought impossible just a few years ago, and the case is only beginning. Imagine being alive in the 1960s when quasars were discovered. Back then, nobody understood what they were. For years, they were just quasi-stellar radio sources, strange objects that defied explanation. Eventually, the pieces came together, and we realized they were powered by supermassive black holes. Today, that's common knowledge. Now, you're in the middle of the next mystery. One day, black hole stars may be as familiar a phrase as quasar. But right now, it's still a whisper, still a clue, still a possibility waiting for proof. And that's part of the wonder. You don't need the final answer to feel the awe. Just the fact that Webb can see this far back to a time when the universe was young and give us a glimpse of something no human has ever witnessed. That's enough to shift your perspective. You're not just watching astronomy, you're watching detective work unfold across billions of years. And if the case leads where the clues are pointing, then you may be alive to witness one of the most astonishing confirmations in the history of science. The proof that stars with black holes at their hearts really walked the universe in its youth. So the detective work continues. Webb keeps its golden eye open. Astronomers keep combing through the evidence, and the universe keeps whispering its secrets, one faint photon at a time. The case isn't closed, but the trail is hot. When you hear the phrase black hole star, it sounds like something out of science fiction, a paradox wrapped in fire and darkness, a concept that feels more like myth than fact. And yet, Webb's faint detection suggests it could be real. But beyond the science, beyond the data and the models, there's a deeper question. What does this mean for us? Because discoveries like this don't just rewrite astrophysics textbooks. They reshape how humanity thinks about itself, about the universe, about our place in it. First, there's the emotional weight of vindication. For decades, quasi-stars were a fringe idea, tucked into papers and whispered about in theory circles. Imagine being one of those scientists who kept the idea alive. You spent your career with colleagues politely smiling, nodding, maybe even dismissing your work. You wrote papers that seemed like science fiction. You dreamed of stars with black holes inside them when the world barely accepted black holes at all. Now, half a century later, a telescope a million miles from Earth may be shining light, literally on your dream. The universe has whispered back, saying, "You were right to wonder." That's more than scientific. That's profoundly human. It's about hope, patience, and the long arc of imagination meeting reality. Then there's the awe factor. As humans, we have always given stars meaning. We charted our journeys by them, wrote poems about them, told stories of gods and heroes who lived among them. They were our symbols of eternity, of permanence, of guidance. But what if some of those stars long ago weren't what they seemed? What if they were monsters hiding secrets? Giants fueled not by the steady fire of fusion, but by a ravenous black hole at their core? That realization doesn't diminish the stars. It deepens them. It shows that even the brightest lights can hold shadows, that creation and destruction aren't opposites, but partners. And in a strange way, doesn't that mirror us? Think about your own life for a moment. How often does growth come not from calm, but from struggle? How often does creativity spring from pain or strength emerge from loss? We like to think of light and darkness as separate, but in reality, they're intertwined. That's what a black hole star is, a cosmic reminder that contradictions can coexist, that something can shine more brilliantly than anything else in the universe, precisely because it is being consumed from within. It's haunting, but it's also strangely comforting. There's also the humility factor. Every time we discover something like this, it reminds us that the universe is stranger than we imagined. That no matter how much we think we know, there are always hidden chapters waiting to be uncovered. For centuries, people thought the heavens were perfect and unchanging. Then we found that stars live and die, that galaxies collide, that black holes exist. Each time, the universe pulled back the curtain a little more, showing us a reality more dramatic and strange than our myths ever dared. The possible discovery of black hole stars is another curtain pull. It tells us that even our wildest guesses from decades ago might only scratch the surface of what's out there. And with that realization comes humility, the recognition that we're still children looking up, still learning to read the story written in the stars. But here's the twist. While humility is part of the lesson, so is empowerment, because this discovery isn't just about the cosmos. It's about us, about what we're capable of. Think about what it took for Webb to even make this observation. Decades of planning, teams of scientists and engineers from around the world, billions of dollars, countless failures, recalculations, sleepless nights, a mirror the size of a tennis court unfolded in deep space, a telescope parked in perfect balance a million miles away. All of that just to catch a faint glow from a star that lived and died more than 13 billion years ago. If humanity can do that, what else can we do? And here lies the emotional punch. Discoveries like this remind you that we are not small, passive observers of the universe. We are participants in it. We are creatures who evolved on a tiny planet and then built machines that can see to the edge of time. We are proof that the universe not only creates stars, but also beings who can wonder about them, beings who can uncover their secrets billions of years later. When you step back and see that arc from black hole stars shaping the first galaxies to humans gazing back at them across cosmic time, you realize that we are not separate from the story of the universe. We are the latest chapter. There's also something deeply emotional in the idea of connection. When Webb detects the light from a potential black hole star, that light has been traveling for over 13 billion years. Think about that. Before Earth formed, before the sun ignited, before our galaxy took shape, that light began its journey. It has been racing through the cosmos untouched, unbroken, until finally, it reached the mirrors of a telescope built by a species that didn't even exist when the light began. You are, in a very real sense, seeing across time, looking not just at history, but at prehistory, at the origins of everything we know. That's not just science, that's poetry. So why does it matter emotionally? Because it reframes how you see yourself. The next time you feel small, lost, or insignificant, remember this. You are made of the same elements forged in the hearts of stars. You are living proof that the universe is capable of knowing itself. You are connected by light and time to the first stars that ever burned, even to those with hearts of darkness. And here's the real twist. Maybe the universe's most brilliant creations, the galaxies, the planets, the life, couldn't have existed without those dark-hearted stars. Without their paradox, you wouldn't be here. You are, in a way, a descendant of black hole stars. So pause and let yourself feel it. The James Webb Telescope hasn't just shown us a faint glow. It has handed us a mirror, a reminder that the universe is full of contradictions, and so are we. That out of darkness comes light, that out of endings come beginnings, that out of chaos comes us. And if a star with a black hole inside it can shine brighter than anything else in the cosmos, maybe we too can embrace our contradictions and shine despite them. So far, the story of the black hole star feels almost too good. A forgotten theory revived, a mysterious signal captured, a cosmic paradox revealed by Webb's golden eye. But science isn't built on awe alone. It's built on doubt. And every discovery, especially one this extraordinary, comes with critics and skeptics ready to poke holes in the idea. And they're right to do so. Imagine you're sitting in a scientific conference. A researcher steps up to the podium and says, "We may have found evidence of a star powered by a black hole at its core." You can almost hear the ripple across the room. Half the audience leans forward in excitement. The other half leans back, arms crossed, sharpening their questions. That's not hostility. That's science. Because extraordinary claims require extraordinary evidence. So, what are the skeptics saying? First, some argue that what Webb saw might not be a black hole star at all, but a very compact galaxy. Galaxies at that distance are hard to resolve. A tight cluster of stars could blur together into a single point of light, tricking our instruments. What looks like one impossibly bright object might actually be thousands of faint ones packed together. Second, there's the quasar argument. Quasars are powered by feeding black holes, and they can shine incredibly bright. Maybe Webb didn't spot a black hole star. Maybe it caught a baby quasar already growing in the early universe. Others point to uncertainties in the models. Simulations of black hole stars are still theoretical. They depend on assumptions about the physics of gas, gravity, and radiation in the early cosmos. If even one of those assumptions is off, the predictions might not hold. In short, skeptics are saying, slow down, don't jump to conclusions. And here's the thing, you should listen to them. Because science without skepticism isn't science, it's belief. And belief, no matter how exciting, isn't enough to uncover truth. The skeptics remind us that Webb is still new. Its instruments are powerful but complex. Data takes time to interpret. Models need refining. Alternative explanations have to be tested and eliminated. Without that process, discovery becomes rumor. But there's another side to skepticism, and it's worth reflecting on. Skepticism isn't the enemy of wonder, it's the partner of wonder. It's the guardrail that keeps science from running wild with fantasy. Without skeptics, we'd risk seeing black hole stars in every bright smudge of light. With them, we're forced to test, refine, prove. And that means if the day comes when black hole stars are confirmed, the discovery will be that much sweeter because it survived the fire of doubt. History is full of examples of this dance between wild ideas and healthy skepticism. When pulsars were first discovered in the 1960s, the signals were so regular that some scientists half-jokingly labeled them LGM, little green men. Critics pushed back. Surely this can't be alien life. Eventually, the truth emerged. Pulsars were rapidly spinning neutron stars, a whole new class of objects no one had imagined before. When dark energy was proposed in the 1990s to explain the accelerating expansion of the universe, critics doubted it. Maybe the data was flawed. Maybe the models were wrong. Today, dark energy is a central mystery of cosmology, supported by mountains of evidence. The same pattern repeats: discovery, skepticism, refinement, eventual acceptance, or rejection. The black hole star idea is right in the middle of that cycle. From an emotional perspective, skepticism can feel deflating. You want the answer to be yes. You want the headline to read, "Webb confirms black hole stars exist." But the critics are the ones keeping you grounded. And maybe that's a lesson not just for science, but for life. Because how often do we jump to conclusions in our own stories? How often do we assume without testing, without questioning? Skepticism, applied wisely, doesn't kill wonder. It protects it. Of course, there's another layer here: the human drama of scientific rivalry. Every bold claim is a chance for debate, for reputations to be made or broken. Some scientists devote years to modeling black hole stars, hoping Webb will prove them right. Others specialize in quasars or galaxy formation and would love nothing more than to show that their models fit the data better. It's not just physics, it's people. People with egos, ambitions, fears, and hopes. People who want to be remembered as the ones who solved the mystery. And in that sense, the discovery of a black hole star isn't just a cosmic story. It's a human story, too. A story of competing ideas colliding, refining each other, driving science forward. So where does this leave you, the listener? In a place of thrilling uncertainty. Because right now, the black hole star is both real and not real, both proven and unproven. It exists in that liminal space where science is at its most exciting, not when all the answers are known, but when the possibilities are wide open. It's like standing at the edge of a mystery novel just before the reveal. You don't know who the culprit is yet, but the clues are on the table. The tension is building, and Webb is the detective turning the next page. If you're looking for the emotional twist here, it's this. The skeptics aren't dampening the magic of the discovery. They're ensuring that when the magic is real, it will last. If Webb's strange object turns out to be something ordinary, then we've still learned something about the limits of our theories. And if it really is a black hole star, then the skeptics will be the first to nod and say, "Now we know." Either way, the universe wins. So the story continues. Webb keeps sending down its golden streams of data. Scientists keep arguing, refining, doubting, imagining, and somewhere out there the truth waits, whether it confirms the black hole star or replaces it with something even stranger. Because if there's one thing history has taught us, it's this: the universe always has another twist waiting. At this point, you might be asking yourself, so what if it's true? And what if it's not? Because the discovery of a black hole star would be monumental. But even if the skeptics are right, even if Webb's strange glow turns out to be something else, The implications are still profound. This isn't just a scientific puzzle, it's an emotional one too. A question of meaning, of story, of what it tells us about who we are. If it's real, let's imagine the most thrilling outcome. Webb has, in fact, captured the light of a black hole star. The emotional impact of that realization is staggering. It would mean that the universe is even more imaginative than we are. That nature doesn't just follow predictable patterns, it invents paradoxes, creates hybrids, writes cosmic poetry into its fabric. The existence of black hole stars would also shift our sense of beginnings. It would tell us that at the dawn of time, creation and destruction were not enemies, but partners. That galaxies may have been seeded by objects that were both stars and black holes at once. Think about what that means for the story of existence. Everything you see, the Milky Way stretched across the night sky, the earth beneath your feet, the air you breathe, might trace its ancestry to stars that were literally devouring themselves. That's not just physics, that's mythology made real. And it adds a layer of beauty. Because if stars with black hole hearts give rise to galaxies, planets, and eventually us, then the universe's most chaotic contradictions are also its most fertile. Life itself might owe a debt to cosmic monsters. For humanity, that's more than a discovery. That's a revelation. If it's not real, but let's flip the script. What if Webb's detection turns out to be a mirage? What if it's just a compact galaxy or a young quasar or some other more ordinary phenomenon? At first, that feels disappointing, like opening a treasure chest and finding it empty. The headlines fade, the buzz dies down. You're left with the dull ache of what might have been. But if you look closer, there's still meaning. Because even a false lead teaches us. If it wasn't a black hole star, then it was something else we didn't fully understand. And that something else pushes the boundaries of knowledge in a different direction. History shows this again and again. Many of astronomy's most famous mistakes turned out to be doorways to greater truths. When early astronomers thought they saw canals on Mars, they were wrong. But the obsession with those canals inspired generations to study the planet, eventually leading to the discovery of a world with its own fascinating history. When scientists thought pulsars might be alien signals, they were wrong. But that wrong guess led to one of the most important discoveries in astrophysics. If Webb's black hole star turns out to be something else, it won't mean failure. It will mean the universe has offered us a riddle we didn't expect, and solving that riddle may reveal truths just as powerful. If it's both, and here's where it gets really interesting. Sometimes science lives in the in-between. What if Webb's detection is partly what we hope and partly what skeptics warn? What if it's not a pure black hole star, but something related, an in-between stage, a cousin, a phenomenon we haven't even named yet? That might be the most exciting outcome of all, because it wouldn't just confirm or deny an old theory. It would open a brand new category of cosmic objects, a fresh page in the catalog of existence. Science often advances in these gray zones, not through neat answers, but through messy ones, through objects that don't fit into boxes, forcing us to redraw the boxes entirely. A star with a black hole inside it may be one such object. Or maybe what Webb has seen is something stranger still, an object we can't yet imagine because we don't have the words. And in that case, both the dreamers and the skeptics would be right. The emotional takeaway. So whether it's real, not real, or somewhere in between, the emotional weight is this. The universe keeps us guessing. It refuses to be predictable. It pushes us to hope, to doubt, to imagine, to revise. And isn't that what keeps us alive intellectually and emotionally? The constant reminder that we don't have all the answers, that there's always another horizon to chase. If black hole stars exist, you'll forever look up at the night sky knowing that some of the first lights in the cosmos were paradoxes, giants with darkness in their hearts. If they don't, You'll still look up knowing that the search itself brought us closer to truth, closer to awe, closer to each other. Either way, you win. Tash, the human mirror. Let's bring it back to you. What if you treated your own life this way? What if you held your own discoveries with both wonder and skepticism? What if you let yourself dream wildly, but also tested those dreams, refined them, questioned them, until the truth, whatever it was, became clear? Whether the answer turns out to be dazzling or ordinary, you'd still grow. You'd still learn. You'd still move forward. That's what science teaches. That's what the Webb telescope reminds us every time it sends back another piece of the puzzle. The meaning isn't only in the